think either with there are a lot of people that are not joining at the moment, so I guess we just proceed with there might be a need for another one another time, but I don't know yet. But for now, we'll just proceed with this one. So I'll be sharing my screen for the presentation that I'll be doing. Add on my screen. Okay, can everyone see my screen? If my screen is showing. Okay, so first of all, I'll be talking to, okay, let me just take out the video. I might not be looking at the screen because I'm using a big monitor. So first of all, we'll be talking about the automated pipeline using Airflow and BigQuery. And this project, um, this presentation for today is a task given to me by the WIDEN, that's the Youth Data Engineering Network. I'm told to discuss about the automating pipeline with Airflow and BigQuery. So I've created a presentation for that. First of all, I need to apologize because the presentation was supposed to be on Sunday, but due to one or two reasons, we were not able to catch up on Sunday. So I postponed it to Wednesday, which is today, 4 p.m. And I'm apologizing for that. Everyone should please forgive me. So first of all, I think I need to talk about myself. My name is Mubarak, a junior data engineer with a classic football share company in the United Kingdom. I've been in the data engineering industry for 2.5 years now, and I've learned to build ETL, Apache flow, and different pipelines for different customers. I've designed efficient data workflows. I've used Apache for orchestration. I've leveraged BigQuery for scalable analysis, and I've worked on some real-world tips for demos and sources. So first of all, I need to talk about the data pipeline. I'm sorry I'm not looking at the screen because I'm using my second monitor, so it's easier focusing on this than this. Or should I just take off I'll just take this off. So talking about the understanding of data pipeline is a series of processes that automate the flow and transformation of data from source to destination. What I'm trying to say here is that it's a process whereby we get data from the sources, which is the online, where, the way we do like Facebook, Twitter, and all those other social medias, there are a lot of information, a lot of data online. So we get the data from this online and we bring it directly to our database. So the process of getting this data online is the process we call our data pipelines. That's the process. Definitely, we all know pipeline is like an instrument where things pass through, or tools rather. So the component of this data pipeline are the sources, the processing, the storage, and the consumers. The sources, these are the APIs, the logs and databases. This is the places where we get our data from, the social media, the databases, and all different sort of sources online. And the processing, which is the ETL. Another name, the full meaning of ETL is the extract, the transform, and the load. We can use the ETL, we can use the ELT. The ELT is the extract, the load, and the transform. I'm supposed to discuss about this in detail, but this is a topic for another time. So we just focus on the transformation in general. So the transformation is the process of converting our data, that's from the dirty form that we brought in to a cleaner form, so we can store it in the data warehouses or the data lakes. In my previous presentation that I did for Widen, I've discussed about a couple of these, but today I won't be going back to that. If there's a need for that, I'll be referring anyone back to those ones. But so the consumers are the people that will be using this data. These are the the consumers are the people that will be using this data. And for them to use this data perfectly, it's difficult for people to understand the way the data work if you don't explain it to them in, should I say, layman tools. So this is when we use the BI tools, the dashboard that we create on Tableau, and different machine learning models. So definitely there's everything we do in life, we have to face certain challenges. So we face some challenges in the data pipelines. I've just itemized just four of the challenges. There are quite a lot, but I can only think of four at the moment that I actually face almost every time. So the reason why we do data pipeline is because most of our activities, we face the challenge of manual processes. That's we process things manually and we're not able to scale them. We face the challenge of lack of visibility and monitoring. If we keep doing things manually, then it's very difficult for us to keep monitoring the way it's going. But if it's automated, I think it's being monitored by itself. We only set like a notification that we get whenever it encounters a problem. Then we face the challenge of difficulty in scheduling and dependencies, and we face one challenge of inefficient query and storage design. This query and storage design has to deal with our BigQuery and Google Cloud Storage. There are quite a lot of databases. There are quite a lot of query. There are quite a lot of different relational tools that we can use. But I basically focus on Google Cloud, that's the BigQuery and GCP. So what is Apache Airflow? Apache Airflow is an open source platform to programmatically auto, schedule, and monitor workflows. There is a current project that I am working on that I'm using Apache Airflow. I would have used that project to explain this better, but for the sake of what do they call it? Data honesty, I can share that. So Apache Airflow is like an open source platform, which is designed. Definitely, the reason why it is called an open source is you can make modifications if you have anyone. But what this basically do is it automates everything we do. It makes it easier instead of us doing them manually. So this is just the process that we use to make the data pipelines effective automatically by itself. So why do we use Airflow? It helps us to visualize our DAG tracking. Whenever we're running projects, we usually have DAGs involved. DAGs are like the steps that each project needs to take to carry out the previous step. So if this step is not done, it can proceed to the next step. So for these steps to be done, it's like we tell the project what to do, step 1 to step 2, then you jump to step 4, you come back to step 3. So this is like the DAG. And we use Airflow to track this. We use Airflow to schedule and retry our logics, and extensible with custom plugins. So the Airflow key concepts, like the DAG, directed acyclic graph. I don't really cram that. I don't keep that in my head. I'm not really concerned about that. All I know is DAG is DAG. This is the pipeline structure. The operators, this defines the task. We can use the Python, the Bash, or the BigQuery, depending on the kind of project we're doing. The task instances, each run of a task. So it's like when we're using the Airflow, sometimes it runs 2 times, sometimes it encounters a problem on the first one, it encounters on the second one, depending on whichever project you're going with. And the scheduler and the executor, this is the way we control the execution flow. So what is Google BigQuery? Google BigQuery is a serverless, scalable data warehouse built for fast SQL analytics. There are some features of Google Query that is common. I started using Google BigQuery for I think 7 months ago or 8 months ago. I'm not really sure. So I'm not 100% like knowledgeable about this, but I think 85.5, I think I can give myself that because it's a really good one. So some features of the Google BigQuery is the petabyte scale querying. You can query like 1 million data at once, unlike using Excel where your screen start hanging, your laptop go wish, everything just, The automatic performance tuning, the federated queries from JCS, Sheet, and more, the integrated ML capabilities, and the use cases for the Google query are like the real-time dashboards, the predictive analysis, and the business reporting. Why do we combine Airflow and Google BigQuery? We combine Airflow and Google BigQuery to automate and schedule SQL workflows using Airflow, easily scale pipelines from hourly to monthly jobs, monitor sources and failures with logs and alerts, optimize performance and cost by managing queries. What this slide is trying to say is that, like I said, we use Airflow to automate everything we're doing in life. I guess even the robot itself uses Airflow. So Airflow is like you tell what the project should do using DAGs. Do this, do this, do this every single day or every single time. Or it depends whether you want to run the task every hour, every month, or every year. Depending on whatever, I can even be running a task every single minute. So you don't need to be going to go and be like activating the DAG every single minute. Once you just set the Airflow with the correct operators, everything just picks up and keeps going by itself. So you have to use Airflow for automation. And the BigQuery is where most of the queries are being run. So I personally used to use the BigQuery to connect to my database. Then I use the Airflow to automate the process. So I use the Airflow to also monitor the sources and failure of logs. So what I do is there is an API that I use to connect my Airflow to Slack. So Slack is like a social media where we usually chat with friends or colleagues that you're working on a project. So whenever my Airflow encounters a problem, it sends me a message directly to my Slack, which tells me that, okay, there's a problem with a particular DAG. You have to correct this and that. So that's also one of the advantages of using Airflow. And it's also used for optimizing performance and costs by managing queries. I think that's an advantage of BigQuery. BigQuery helps us to optimize our cost and manage queries. I would have loved to show a sample of this, like I said. Currently on my system here, I have the Google Cloud Storage, the GCS, the Airflow, and the BigQuery opened on my system, but for data integrity sake, I can show that. And I don't really have any sample project that I'm working on at the moment. Maybe for next time, then I can get prepared. But for now, I can't really show a sample architecture of the way data is being ingested from an API and stored into the Google Cloud Storage, and the way the Airflow also triggers the DAGs for transformation. I listed this for basically when I was writing this slide that I'll be using it to show some presentations, but unfortunately, I'm very sorry I couldn't really get this particular tasks, these particular presentations up. Same thing with the demo. So I'm going to skip this. So the performance and the cost optimization tips. So I have to rush this now because I just have 7 minutes left to finish this presentation. In Airflow, some of the tips we use to optimize our cost is we use sensors and dependency management. We leverage SCOMs carefully. We enable retries and notifications. While in BigQuery, we partition and cluster large tables. We avoid select all in queries. We use table expiration for temporary data, and we enable flat rate pricing for high volume usage. I've already prepared a slide for this one for another day, but currently I won't be discussing about these optimization tips. But that's a slide probably for next month's presentation if Widen permits me to do the presentation again, but that's not for today. Then the real use cases. This was the project I was working on last week, the Tapfiliate conversion pipeline. So what I do is my company usually, about this project, just a brief about this project. My company is a clothing company, we sell jersey and everything. So there are a lot of people that buy all these items online. We have the information and, with data, everything is possible. So Tapfiliate is a company that helps us to store the data online. So what I was supposed to do was to build an ETL that brings the data from the API of the Tapfiliate, store the data in Google Cloud Storage, then from Google Cloud Storage to BigQuery to be used, you get. So I built an ETL for all this process and I used an Airflow. So what I use the Airflow for is to be automating it every single day. By 6 a.m., it gets the recent data of the people that just purchased for that previous day. Sometimes I think I had a problem, so I had to change it to 2 hours. But most of the time, it's just usually 6 a.m. in the morning. I like to run I like my Airflow to pick up my DAGs, and that's it. So the goal of this project, now let me go back to the script, is to automate the Tapfiliate API conversions to Google BigQuery. And the process was, I built a Python script that fetches the conversion from Tapfiliate. It stores the data in the GCS as a packet file. So packet file is also another file, like the common one. We know Excel file, we know CSV file. There's a packet file too. So it saves the data in GCS as a packet file. Then I built an Airflow DAG that loads the data into a staging table, then merges it into a final table. Okay, I have 4 minutes left. And so I modified my Airflow to be scheduled every two hours. So what it does is every two hours, it remodifies like the table, it reloads the table to get the most updated set of people that have just purchased like recently. So it brings the data in. And what this did was it has reduced the manual effort by 95% and enabled real-time reporting. So the key takeaways. The advantages of using Airflow, or basically the reason why I feel like everyone should be using Airflow, is because Airflow allows you to scale and automate complex workflow, like I've said that before. It makes everything easier. BigQuery provides power and flexibility for large-scale analytics. And together, when you combine these two, trust me, they're unstoppable. Like they make engineering more interesting, efficient, reliable, cost-effective, and what have you, anyone you can just think of. So we've come to the end of the slide. I think I was able to speed this up within the time given by Zoom just to finish this fast. And if anyone has a question that is urgent, you can drop that while I read and respond. But because of time, you can just